Okay, hello everyone. So let us now proceed to sum and difference identities and co-function identities. Okay, so we'll do some exercises using these identities. Okay, so for sum and difference identities, we can use these identities if we are tasked to calculate the exact value of certain angles. And for example, if we do not know, if for example, if you take a look at the unit circle and the angle is not specified in here, it's not pi over 3, pi over 4, or pi over 6. It's none of these. Then if we can express these that angle as a sum or difference of these angles that we are familiar with right here, or indicated in this unit circle right here, then we can calculate it without using any calculator. Okay, so let us do some examples here. So for example, and we are given find the exact value of cosine 5 pi over 4 minus pi over 6. Okay, so this is rather easy because the angles here are already in this particular unit circle, right? We have 5 pi over 4 and we also have pi over 6 here. Okay, so let's just substitute this into the formula. So this is just to get to familiarize the use of the formula. So since we know that cosine, if we look into the table, we can see that this is the form that we're going to use. So cosine, so from that formula, we can then say that this is equal to what? So this is equal to cosine of 5 pi over 4, right? Multiplied by the cosine of pi over 6. And then we add that to the sine of, same thing, 5 pi over 4. And also, oh wait. Let's just rewrite this. It's too cramped. Sine pi over 5 pi over 4. And then also sine pi over 6. Okay, so if we take a look at our unit circle, we have here cosine of 5 pi over 4, and we know that the cosine is the x component, right? So we get negative square root of 2 all over 2, right? So this is the 1. And then after that, we multiply it by cosine pi over 6. Now cosine pi over 6 is a square root of 3 all over 2. Okay? So we then add that to sine 5 pi over 4. So sine is the y component of 5 pi over 4 here. So we get negative square root of 2 over 2. And then for the sine pi over 6, we get 1 half. So it's just a matter of evaluating this. So we get from the law of exponents, we get negative square root of 6 all over 4. And then add that to negative square root of 2 all over 4. So we will get negative square root of 6 over 4 minus square root of 2. Right? Square root of 2 all over 4. So we will get this one. So negative square root of 6 minus square root of 2 all over 4. Okay, so this is our answer. Okay, so let us proceed to the second example. So our second example is find the exact value of 75 degrees. Okay, so what's this? I'm sorry for this. This is supposed to be cosine 75 degrees. Okay, so cosine 75 degrees. 75 degrees is not here in our known angles here in the unit circle, but we can express it as what they call this, a sum of two angles. So we can say that this is equal to cosine as 30 plus 45, right? So 30 degrees plus 45 degrees. Okay, or let's express it in a radian form. So cosine pi over 6 plus pi over 4. Okay, so let us now take a look at what formula we're going to use. So we're going to use this right here, right? This right here. Okay, so instead of a plus sign, we get a minus sign. So let's do it. So we get, let's just write it below. So this is equal to cosine of pi over 6 multiplied by the cosine of pi over 4, and then minus sine of pi over 6 over the sine of pi over 4. Okay, so if we take a look at the unit circle, I think it would be best if we transfer. Let's transfer to the top. Let's delete this first. So let's tidy this up a little bit. And let's transfer this here. Okay, here. Okay, so we have here the cosine pi over 6. So where is pi over 6? Cosine pi over 6 is what? Square root of 3 over 2. Okay, so let's write that down. That's square root of 3 all over 2 multiplied by cosine pi over 4. Cosine pi over 4 is this one, right? So this is square root of 2 all over 2. Okay, square root of 2 all over 2. And then minus sine pi over 6, we will get 1 half. And then sine pi over 4, so it's the same thing. So square root of 2 all over 2. Okay, so let's evaluate this. We will get square root of 6 all over 4 minus square root of 2 all over 4. So we can then simplify this even further by square root of 6 minus square root of 2. Okay, so this is our answer. Okay, so let us now proceed to cofunction identities. So cofunctions are pairs of trigonometric functions that have equal values when their arguments are complementary angles. So as you can see here in um, the table, as you can see here, we have here sine and cosine are cofunctions, and tangent and cotangent are cofunctions, and also secant and cosecant are cofunctions. Okay, so how are we going to apply these identities? So let us do some examples. Okay, so example number 1. So if cosine pi over 2 minus a, so this is a simple application. So number 4, what is a? What is a? Given that a is greater than 0 and lesser than pi over 2. Okay, so from the cofunction identities, we can see that cosine of pi over 2 minus a is equal to what? So cosine of, so we can see it right here. So this is actually equal to sine theta, right? Sine theta, or in this case, sine a. So sine a is equal to sine pi over 4. So if we want to find a, so if this equality is true, then therefore a is equal to pi over 4, right? Because they're both, we use the sine function on both of these angles, and they are equal, therefore a is equal to pi over 4. Okay? Okay, we have here our second example. So given that a and b are complementary acute angles, then square root of cosine a over sine b minus cosine a sine b is equal to what? So basically, we are going to simplify this expression right here. So the key here is that a and b are complementary. Therefore, if we select the sine b, we can actually express b as pi over 2 minus a, right? Because a and b are complementary. So from the cofunction identities, we can then say that this is equal to cosine of a, right? Sine b is equal to cosine of a. So there you have it. So if we substitute that, get cosine A over cosine A minus cosine A, and sine B is equal to cosine A again. So we get all cosine A here. So cosine A. So we will get square root of 1 minus cosine squared A, right? So from the Pythagorean identities, this is equal to sine A, right? Sine A. Okay, so that is our answer. Okay, so thank you for watching this video. I hope you learned something, and see you in the next videos.